So, good morning everybody. Today we will be discussing on the another module of this course, advances in welding and joining technologies. So, that is related to that welding metallurgy. This is also a part of the complete course, and the purpose of this covering this welding metallurgy is that probably some metallurgical understanding or some reactions happening during the welding is helpful to decide the type of welding processes, or sometimes this critical analysis of this welding metallurgy also necessary to avoid to produce some kind of defects in during the fusion welding processes or as well as other solid state welding processes. So, we will try to get some basic idea metallurgical aspects related to welding processes. So, this module welding metallurgy we will try to cover that first is we will try to look into that chemical reactions that is happening in welding process. Second is the one of the most intricate part of welding, that residual stress and distortion, that is the most serious problem happens, and of course, this residual stress and distortion having the link with the metallurgical changes that happens during the welding process. And then we will try to basic fundamental understanding of the solidification and in specific to welding processes, and what are the typical weld microstructure and what is the nature of the microstructure actually developed during the welding process, and probably how we can control this weld microstructure during the process, so that we can expect some desired properties in the final weld joint. So, that microstructure is more related to the weld joint properties. So, it is very much indeed is needed to know some idea, basic idea about the weld microstructure. Then we will try to look into that phase transformation happens, is maybe the solid state phase transformation, or what are the consequence of the when there is a solidification happens from liquid phase to the solid phase during the welding process, and how this phase transformation actually affects the final or influence the final weld joint. Then we will try to look into that specifically the formation of the cracking, and in very specific to the solidification cracking, that is the most severe problem in the welding of a specific in presence of the specific components within the weld. So, that is why we will try to look into that solidification cracking in that happens during the welding process. And finally, some basic idea that heat treatment of the weld joint. So, we have the idea about the heat treatment processes, but we will try to look into that basic things is heat treatment, how it is possible to apply in case of specific weld joint. So, with this I can start with the several components of this module. First will the what are the chemical reaction that happens during the welding process. So, that if we look into that chemical reactions basically happens during the welding process. So, we will try to look into the basic aspects, that what are the effect of structural changes happens during the joining of the similar and dissimilar materials, and that structurally changes due to presence of or using of different type of shielding gas or any other kind of shielding to the molten weld pool, and then how it react with the molten weld pool and making whether it helps or into some helps in microstructure formation, or it may not help in the microstructure formation, but helps in other aspects also. Second, that definitely we know that weld quality, that means final weld joint in terms of joint strain, their mechanical properties of the weld joint, that is the mostly we are interested, and the life of the weld joint, that definitely depends on the welding metallurgy. So, that is why it is necessary to study this welding metallurgy, and how this welding metallurgy depends on the several parameters involved in the welding processes. Third point is that selection of the proper shielding medium, it is also necessary, that selection of the shielding, anyway shielding gas is obvious necessary to use in the welding processes, but proper shielding gas is need to choose, because it actually finally affects the formation of the different types of weld defects. And suitable welding processes or suitable pre-measurement of the workpiece sample, so that it will finally try to reduce the residual stress and generation of any kind of the distortion. Anyway, in fusion welding processes always it is subjected to some amount of the residual stress and distortion. We cannot avoid this. Only what we can do, that we will try to reduce the amount of the residual stress and distortion, or if the residual stress is beneficial to some extent, that we will try to maximize that component, but most of the cases residual stress is basically not favored in a life of the weld joint. So, that is why our objective should be always to minimize the amount of the residual stress generation, and of course, the amount to reduce the distortion, because distortion is basically affect the dimensional accuracy of the two components when we are supposed to join. But all these aspects is mostly influenced by the solidification mode, or maybe the final weld structure or final microstructure of the weld joint. So, therefore, microstructure, actually formation of the microstructure is highly related to the whether we can get very sound weld joint or not. So, therefore, that study and the effect of the different process parameter is actually necessary, because the microstructure can be developed in the fusion zone and that microstructure can be controlled. So, there are several control mechanisms, so that we can control the microstructure, and indirectly this microstructure also affects the generation of the residual stress along with the other conditions, but the distortion residual stress also influenced by the presence of the microstructure. So, that stress generation, distortion and formation of the microstructure, they actually linked with respect to each other. Therefore, they are interactive phenomena, it needs to investigate or needs to know here, but it is not possible to cover in details analysis of all the microstructural phenomena in this module. We will try to look into some basic concept that generally happens during the welding process, so that we have some idea that nature and type of the microstructure can be developed in the welding processes, and of course, that we can link the different type of the process parameters or microstructure, what is the in terms of the or that influence the amount of the residual stress and distortion. So, in that respect, first we will look into that what are the chemical reactions in welding is generally happens. So, broadly we can categorize the during the overall, if you look into overall all the type of the welding processes. So, we can use that gas, basically shielding gas, to protect the molten pool. So, therefore, we need to know the interaction between the gas and molten oil pool, or when the molten oil pool becomes solidified, how the what is the reaction happens between the these two components, that is also need to know, and this is the one way. Another way to protect the molten pool is the in terms of the using the some slag. So, therefore, slag metal reaction also important to know, analyze, to know, to finally to that influence the weld joint strength. So, these two mode, either using shielding gas or either using the slag, probably the purpose is to protect the only the molten oil pool during the welding processes. But why it is important? Because high temperature during the welding involves, fusion welding specifically, they involve high temperature generation. So, that high temperature, the chemical, actually it promotes the chemical reaction with the surrounding atmosphere. So, when it reacts with the surrounding the molten oil pool reacts with the surrounding atmosphere, because tendency increases even at room temperature to at very high temperature. So, that probability is the entrapment of the gas can be dissolved in the oil pool, and they can create the porosity or kind of hole or kind of some other defects, or there may be the they can form the some inclusions also when it is when the molten oil pool react with the outside atmosphere. So, therefore, this type of interaction or this type of chemical reaction of the molten oil pool with the surrounding atmosphere can be controlled and by the way using the proper shielding gas or using the proper slag material, so that it will be able to protect the molten pool during the welding process. So, other way also that this chemical reaction can be reduced simply by cleaning the base metal, because most of the cases we can find out the when you the layer of the metallic oxides, and of course, we use the several electrode during the welding process. So, before using that, if we clean the workpiece surface and the electrode material, probably we can reduce some amount of the contamination of the molten oil pool. So, finally, because finally the chemical reactions is basically affects the final weld joint properties, or it can alter the weld composition. It becomes the part of the weld composition or becomes part of the final composition of the weld joint strength, and that actually indirectly affects the mechanical properties of the weld joint. So, that chemical reaction find out that first some investigation has been carried out, that I think if you look into that reference, Aerokin actually first investigated what is the effect of the shielding gas in welding processes. So, he conducted the experiments on low carbon steel without any shielding gas, simply creating the arc, but with no shielding gas the weld was conducted, and then the properties difference in the different properties we can tabulate it in the here, that mechanical properties. If we see the tensile strength, base metal, what is the range, I think Newton per millimeter square 390 to 440, but weld metal without any shielding gas found out that there is a decrement of the joint strength 334 to 390, and there is a considerable decrement of the ductility of the weld joint, and of course, toughness, there is a huge reduction in the toughness of the weld joint. So, there is a degradation of the weld joint properties as compared to the base metal if we do the welding without any shielding gas. So, that is why shielding, there is a necessary to use some shielding gas to protect the molten pool. Here if we see that that high oxygen, nitrogen and mainly the oxygen and nitrogen content was found in the weld joint. So, around 0.7% oxygen and around 0.2% nitrogen actually found out with the plain weld metal if you do not use any kind of the shielding gas. That means, during the welding process at this high temperature, the molten oil pool actually react with the surrounding atmosphere, and then oxygen and nitrogen actually absorb within the molten pool or mixes within the molten pool. So, definitely this amount of the oxygen and hydrogen usually comes from the atmosphere, or there may be other source of this contamination or present there is oxygen and nitrogen that may come also from the moisture, that moist air can come from the moist air, or that base metal surface and the dirt on the base metal surface, sometimes we use some chemical agent on the base metal surface. So, that can be a source of this oxygen or nitrogen, and finally, it reacts with this the oxygen.